Alright, before we dive into the details, I want to set the stage. Today is all about breaking down some misconceptions people have about deep learning and AI. There's a lot of hype out there, so much, honestly, that it's easy to get swept up in it.
That hype is everywhere. You see headlines promising AI will solve absolutely everything, but when you dig deeper, there's a lot more going on. I think it's so important we slow down and look at the real challenges hiding behind the buzz.
Exactly. We'll start by clarifying what deep learning really is, how it relates to machine learning, and then work through the real sticking points that most people miss.
Sounds good. And I have to say, sometimes even the basics get a bit tangled up. Maybe we could kick things off with that deep learning versus machine learning distinction?
Let's do it. So, deep learning is actually a branch of machine learning that uses neural networks with multiple layers. Think of it kind of like a stack of experts, each one specializing in different features of the data.
I like that visual. And if I remember, in deep learning, you don't always have to label your data. The system figures out patterns, sort of like giving it a tub of Legos and letting it decide what to build, right?
That's the gist. In contrast, classic machine learning needs that labeled data. Someone has to tell the system what's what before it can learn. So humans do more prep work up front.
It's wild how much that difference matters. But deep learning brings its own set of headaches, which is where so many misconceptions creep in.
So many folks think deep learning is a magical fix-all, like suddenly medicine will be solved, world hunger gone, and robots will do our homework. Clearly, the reality is a lot messier.
Yeah, that optimism is tempting, but it's a double-edged sword. The real promise is huge, like finding patterns in massive sets of data we'd miss, but it's not a universal cure. We really need to keep our critical thinking hats on.
That's the key point. I always tell my students, don't swallow the hype whole. Media tends to overpromise on what AI can do, and it leads to disappointment or even risky decisions.
And sometimes the loudest critics are the ones who understand how far we still have to go, especially if we're talking about achieving general intelligence. That's still science fiction territory.
Jumping off that, let's talk about deep learning's appetite for data. Unlike humans, who can learn from a couple of examples, these systems need mountains of information just to get started.
That contrast always blows my mind. You give a person a few calculus problems, and they pick up the concept. Deep learning? It needs thousands or millions of labeled samples just to get its bearings.
Which is a huge problem if you're dealing with rare diseases or any field where data is scarce. There simply isn't enough information to feed the beast, so to speak.
And don't forget, somebody has to label that data. That's slow, expensive, and sometimes just not possible in the real world.
That brings up a big point. Not everyone has access to boatloads of data. Smaller companies or those in privacy-sensitive industries might not be able to use deep learning at all.
It's kind of ironic AI could level the playing field, but if only the tech giants can afford the data, it might actually make things less fair. I've wondered what it means for innovation if startups can't compete.
Exactly. Some people even predict we'll see one-person billion-dollar companies powered by AI. But if the barriers stay high, that potential could evaporate. We'll need to find ways for smaller players to access or generate useful data.
It's an opportunity and a risk rolled into one. If we get it right, anyone could build something new. If not, we risk massive unemployment and stifled creativity.
Let's shift gears to maybe the most notorious issue, the black box problem. These systems are incredibly complex, with millions of parameters, and even the creators can't always explain how a decision was made.
That's honestly scary. If you can't trace the reasoning, how do you trust the outcome? Especially in high-stakes fields like medicine or self-driving cars. If something goes wrong, who's responsible?
Right. Liability becomes a huge issue. Is it the company that built the model, the business using it, or even the hardware manufacturer? Until we can peek inside that black box, trust and accountability stay out of reach.
And that lack of transparency makes it tough to regulate or improve safety. It's a real challenge for policymakers and engineers alike.
That's a natural segue to regulation and ethics. Transparency isn't just a technical thing, it's also about making sure AI is safe, fair, and accountable. But regulations can lag way behind the tech.
It's a bit of a catch-22. Too much regulation stifles innovation, too little and we risk harm. I've seen big companies start funding explainability research, not just for PR, but to actually help people trust the systems.
Explainability is going to be a massive field in its own right, and for smaller research teams, the challenge is also about access to enough computational power to experiment and improve these models.
Honestly, I hope more tech giants step up to offer computational resources for this kind of work, not just splashy donations. The stakes are too high to ignore.
So let's talk about language. Deep learning models are getting better, but they still fall short at understanding the real structure and context of long, complex conversations.
It's so true. If you try to have a long chat with a language model, it quickly loses the thread. It's not really keeping a mental map like we do, just predicting the next word based on probability.
Exactly. They don't have a sense of hierarchy or the big picture. In a way, their memory is more like a goldfish than a diligent note-taker.
And that's why they struggle with context-heavy tasks or remembering details from earlier in a discussion. It's a real bottleneck for applications like virtual assistants or chatbots.
Another pain point: AI lacks common sense, so it's easily tripped up by jokes, sarcasm, or even absurd questions. Sometimes it just can't tell what's plausible and what's nonsense.
Like that story of the AI asked how to end world conflict, and because its data was so skewed towards military strategy, it spit out a wildly destructive answer. It just didn't know any better.
That's a key example of how data bias and lack of real-world reasoning can lead to unintended, sometimes dangerous results. It's a reminder that AI isn't smart in a human way.
It can't feel or intuit the way we do, so it needs guardrails and constant oversight, especially in sensitive or unpredictable situations.
Let's zoom in on conceptual thinking. Deep learning models are fantastic at finding patterns, but they just don't grasp abstract concepts or imagine new ideas. Newton and Beethoven would be out of business if we relied on AI for originality.
That's such a good point. AI can remix existing data, but it can't create the next symphony or write a novel from scratch. And it mostly finds correlations, not true cause and effect relationships.
Right, so if you're looking for creativity or understanding of deeper meaning, you need a human. AI is like an overachieving statistics student, not a philosopher or artist.
Which is why it struggles outside narrow, well-defined domains. The lack of true conceptual leap sets a clear boundary we have to recognize.
Thinking about prior knowledge, AI has almost no real memory. It can't easily transfer what it learned in one area to something totally new. That's a key reason why it works best in static, predictable environments.
Self-driving cars are a great example. A tiny sticker on a stop sign and the car gets confused. Changing conditions throw these systems for a loop because they're not built for flexibility.
Even recommendation systems, like those on Netflix, often miss the mark. They're using simple statistical guesses, not really understanding your preferences.
And when you try to retrain AI for a new field, it's almost starting from scratch. Human brains are just so much better at adapting on the fly.
Let's tackle overfitting. This happens when a model memorizes its training data so well it can't handle anything new. The butterfly effect kicks in. A tiny change can throw off the whole system.
You see it with self-driving cars. One little sticker on a sign and the car's logic falls apart. Overfitted models are brittle and can't generalize, which means they flop when faced with the real world.
And that brittleness undermines trust. If we can't rely on AI to handle minor variations, it's hard to put it to work outside the lab.
That's why robust testing and diverse training data are so critical. Otherwise, the model's just memorizing the answers, like a student cramming for a test they never really understand.
We can't forget how resource-intensive deep learning is. Training these models takes massive computing power and energy, not something every company can afford.
That's a huge barrier for both startups and researchers. And even with cloud solutions, the bills add up. Plus, models still struggle with language nuance, especially when dealing with accents or subtle meanings.
Right, we're seeing some clever workarounds, like training on audio waveforms instead of just words. But the complexity keeps ramping up, along with the costs.
Which circles back to our earlier point. If only a few players can afford to play, we risk concentrating power and missing out on a diversity of innovations.
So, after all that, it's clear deep learning can't go it alone. The future is probably in hybrid approaches, mixing deep learning with other AI methods and keeping humans in the loop.
I like that outlook. Getting stuck on one technique is a recipe for stagnation. Exploring new ideas, even if they feel risky, is how we'll get closer to truly robust artificial intelligence.
Exactly. The worst thing we could do is just stick with what works now and call it a day. We need to encourage innovation, take some risks, and push the boundaries.
And that means everyone in this space, not just engineers, should be thinking critically about where AI fits into their field and how to build on its strengths without getting blinded by the hype.